Section 4.3 is graphing quadratic equations, and quadratic equations means what? How do you recognize them? Second degree equations. In section 2.3, we had our linear equations or first degree equations. In what section was that? 3.5, we talked about the library of functions, and we could graph basic linear equations, quadratic equations, radical equations, absolute value equations, but we just used what we knew about that library of functions, and then what shifts graphs left, right, up, or down. Our quadratic equations, we didn't go into a great deal of detail. We just said, hey, it's a parabola. If the leading coefficient's positive, it's concave up. If it's negative, it's concave down. And then look for that critical point, which is obtained by knowing what shifts the graph left, right, up, and down. And I told you then that we would talk more in detail about the graphs of quadratic functions today. There are some other things that I want you to know other than just the critical point. By the way, the critical point of a parabola is called its vertex. So we're going to know more about the parabola rather than just knowing its concavity and its vertex. Actually, let's see, the example 1 and the example 2 that I have on this handout are almost identical to the first two problems on test 3. Quadratic equations can be given to you in two different forms. My Roman numeral 1 is vertex form, where you can just look at the equation and see the vertex, and then my Roman numeral 2 is standard form, where you have to use a little bitty formula to find the vertex because you can't just look at the equation and see it. First, though, make sure you know how to recognize the quadratic equation. Second degree, this is a second degree equation in standard form, and the graph of that second degree equation is called a parabola. The very simplest parabola is y equals x squared. You already know, I could have given you that on the last test, and you would have known it's a parabola with vertex 0, 0, because it hasn't been shifted left, right, up, or down. We didn't worry about precise width, but if you want to know precise width, you could just make a little XY chart, choose a couple points on either side of the vertex, and that will give you the precise width of the parabola. I'm just going to put 0, 0 in the middle of my XY chart, and then go back to let x be -1 and x up to +1, and just square those x's to get the y's that go with them. If you square -1, you get +1. If you square 1, you get 1. So here's a quick sketch of your simplest parabola. That 0, 0 is the vertex. You could say that this parabola is concave up. What about the domain of that function? Either looking at the equation or looking at the graph, you should be able to tell me the domain or how far the x's go left and right. What are they? Yeah, that graph goes forever to the left, forever to the right, so the domain is -infinity to infinity. How about the range of that function? What can the y's be? The lowest y value on the graph is 0, and how high does it go? To infinity. So the range of that function is from 0 to infinity, including the 0. Something else that we didn't mention in the last chapter was this vertical line. It's hard to put a dotted line on top of a solid line, but you can imagine a vertical line going right through the vertex, along which you could fold that parabola and the two sides would match up. They're mirror images of each other. That vertical line through the vertex is called the axis of symmetry. which makes sense because it's the axis or line along which you could fold the parabola and the two sides would match. That's what symmetry means. For this parabola, the axis of symmetry goes through the origin, but if my parabola is shifted left or right, then the axis of symmetry will be something else. What's the equation of this vertical line through the vertex? What's the equation of the y-axis? What kind of equation gives you a vertical line? X equals gives you a vertical line. The y-axis is the line on which all x's are 0. So x equals 0 actually is the equation of the y-axis. The x-intercept is where the graph touches the x-axis. Where is that? At the origin, and the y-intercept is where the graph touches the y-axis. For this parabola, both the x and the y-intercepts are the origin. That's the only place the graph touches either one of the axes. So the x and y-intercepts are 0, 0. And then one other term we're going to mention is the extreme value of the function. Every parabola, every up and down parabola, up or down parabola in the whole wide world is either going to have an absolute highest point or an absolute lowest point, depending on whether the parabola is concave up or concave down. Those absolute highest and lowest points are important. For example, in business, you want to know where your profit is at its highest point. In physics, you might want to know when a projectile is at its highest point. In chemistry, you might want to know where the pressure of some gas is at its lowest point. So those extreme values are important. Here, since we have a concave up parabola, there's an extreme lowest point. That's called the extreme value of the function, or in this case, it would be called the minimum value of the function. The extreme value is always the y value, the highest y value or the lowest y value, depending on whether the function's concave up or concave down. So the extreme value here is y equals 0. And more specifically, we can say y equals 0 is the minimum value of the function. Or just y equals 0 is the minimum. The words extreme value can indicate minimum or maximum, so you have to specify what type of extreme value you have. All right, those are the details that we're going to look for in all the parabolas that we graphed today, and all of my examples and the test are laid out so that you have parts A through I, and we'll make sure that you understand how to find each one of those parts. Before we do that, though, let's talk about one other example, f of x equals negative x squared. What's the biggest difference between that simplest parabola and the second example? It's concave down. That's the biggest difference. That causes some other things to change, but that's the main thing that changes. It's concave down because of that negative coefficient. And if in the homework or on the test you're graphing a parabola, make sure that you pay attention right off the bat to whether this is supposed to be a concave up or concave down parabola, because if you see that leading coefficient's negative, and you know the parabola is supposed to be concave down, but yet when you make an XY chart, you get a parabola that's concave up, at least you know something's wrong. You have to go back and find your mistake and fix it, but you should not get a concave up parabola from a quadratic equation that has a negative leading coefficient. We could let x be the same -1, 0, and 1 that we did for the first example. And a lot of folks punch this wrong on the calculator. Hopefully you don't have to have a calculator for this particular equation, but on bigger equations, sometimes folks punch it wrong when they have a negative leading coefficient and then plug in a negative number. If you put a -1 in place of that x, let me say this. Negative x squared means the same thing as -1 times x squared, right? That negative is not being squared. According to the order of operations, what would you do first, the exponent or the multiplication? The exponent. So when you put a -1 in place of x, make sure you square that -1, get a +1, and then multiply it by the -1. If x is -1, y is -1. If x is 0, y is 0. And if x is 1, again, square it, you get a 1, and then multiply by -1. That's what makes your parabola concave down. So watch out for how you punch that -x squared on the calculator. Maybe the best thing to do is punch it as -1 times x squared, and then you'll be more likely to get those y values correct. We're not going to write down all of the same stuff. A lot of it's the same as for the concave up parabola. The domain is still -infinity to infinity. The range has changed. What's the range of this function? Make sure you give it to me lowest to highest. -infinity up to 0. 0's the highest y value on that graph. So -infinity to 0, including the 0. The axis of symmetry would still be the same because the vertex here is the origin. The x and the y intercepts are still 0, 0. The extreme value is still y equals 0, but now it's not the minimum value of the function, it's the maximum value. It's the highest point on that graph. This would be a very unfortunate equation to have as the profit function for your business. If this was the profit function of your business, the absolute best you could ever hope to do is break even, because 0 is the highest y value. Anything other than this particular point, you're going to be losing money. So if you are an entrepreneur someday, I hope that that's not your profit function. All right. What about graphs that have been shifted left, right, up, or down? If you look at this vertex form, we already know this. We know that whatever's added or subtracted before the x is squared, or if this were a different function, it might be before the x is cubed, or before you take the absolute value, or before you take the square root. Whatever you do before you apply the function, that's your horizontal shift. And that horizontal shift, just like in chapter 3, works the opposite of what you expect. Adding something to x actually moves the parabola to the left. Subtracting something from x actually moves it to the right. But it's whatever is added or subtracted inside the parentheses before the squaring, that's your horizontal shift. And whatever is added or subtracted after the squaring, that's your vertical shift. And the vertical shift works more like you would expect it to. Adding moves your graph up, subtracting moves it down. This A determines two things. It determines the concavity, whether the parabola is concave up or concave down. It also affects the width But if I'm being precise about width, I'm just going to make a 3-point XY chart with my vertex in the middle. If you go one to the left of the vertex and one to the right of the vertex, then your parabola will have the exact right width without you having to memorize. If A is greater than 1, it's more narrow. If A is less than 1, it's more wide. I'd rather you just make 2 more points on the graph than have to memorize that. So these are the things that we're going to be looking for on every example. If the leading coefficient is negative, it's concave down. If the leading coefficient is positive, the parabola is concave up. The vertex is going to be determined by this horizontal and vertical shift. If you start at the origin and count h units horizontally and k units vertically, your vertex is now going to be at whatever h and k are. So vertex form is where you can just look at the equation and see the vertex. For example, down here in example 1, this parabola has been shifted how horizontally? 5 to the right and down 4. So if you started at 0, 0 and counted 5 to the right and down 4, what's the vertex of that parabola? 5, 4. Oh, yes, I'm sorry, 5, negative 4. We're just going to be lazy sometimes and say the opposite of the guy in parentheses and the guy on the end. That's the horizontal and vertical shift. So that's how we find the vertex, the axis of symmetry. We're only going to talk about in this section parabolas that open either up or down. So the axis of symmetry is always going to be a vertical line. The fact that it's a vertical line means the equation is going to be x equals something. And the fact that it goes through the origin means x is going to be whatever you wrote for the x coordinate of the vertex. The y-intercept, with linear equations, how did we find a y-intercept, the point that the graph crossed the y-axis? Think about it. If we had a line and we wanted to know its y-intercept, or where it crossed the y-axis, what's true of any point that's sitting on the y-axis? X is 0. So anytime, it doesn't have to be a line, any equation, if you want to find its y-intercept, you let x be 0. That's what f of 0 means. Let x be 0. And the x-intercepts are found by letting y be 0. Because if you're looking for the point where a graph crosses the x-axis, all the points on the x-axis have y equals 0. So you let y be 0, that's equivalent to letting the whole function equal 0, and you solve that equation. Now, on happy problems, you can solve the equation by factoring. But since this is a quadratic equation, if you can't solve it by factoring, what can you always use as your fallback method? Quadratic formula, all right? Most of the problems in the homework, you can factor to find the x-intercepts, but on 1 or 2 of them, you may have to use the quadratic formula. Then you're going to graph the function. It's easier for me to find the domain and range looking at the graph. Well, actually, the domain for any quadratic function is going to be negative infinity to infinity because you can let x be anything. All of these parabolas are going to go from forever to the left to forever to the right. So all of their domains are negative infinity to infinity. But the range is easier to list after I've graphed the function. If the parabola is concave up, is that extreme value going to be a minimum or a maximum? Minimum, and if it's concave down, that extreme value is going to be a maximum. All right, so the range is just the lowest y to the highest y, and then the extreme value is always the y value. Did I write that somewhere? That k is the y value of the vertex. So that k is a minimum for a concave up parabola or a maximum for a concave down parabola. Let's find all those things for this example. Number one, I can look at it very quickly and tell you that that parabola is going to be concave. How? Up, because the leading coefficient is 1. That's the first thing I need to make a note of. The vertex of that parabola, you told me, is what? Positive 5, negative 4, because that horizontal shift is what's added or subtracted inside the parentheses before the squaring, and it's always kind of the opposite of what you expect. And that negative 4 is your vertical shift. So the vertex is 5, negative 4. At this point, I would go ahead and make a little XY chart because I am being more particular about the width here. I'm going to put the vertex in the middle and then just go one to the left of the vertex and one to the right of the vertex to make sure I have the correct width for the parabola. One to the left of 5 is 3, and one to the right of, no, it's not. I can do calculus, I just can't count. One to the left of 5 is 4. One to the right of 5 is 6. And then you can maybe do this in your head or punch it straight left to right on the calculator. It makes me happy if you can just say 4 minus 5 is negative 1. Negative 1 squared is 1. And 1 minus 4 is negative 3. But if you don't care about making me happy, then just grab your calculator and make sure you use parentheses. Punch open parenthesis, 4 minus 5, close parenthesis, hit your square button. Don't forget the minus 4 equals, and you get the same negative 3. The other nice thing about making your XY chart is it helps you make sure you have the correct vertex. What if you forgot that you were supposed to take the opposite of that horizontal shift and you put negative 5 here? Let me show you what happens if you do this correctly, and then I'll tell you what happens if you do it incorrectly. If you let x be 6, then 6 minus 5 is 1, 1 squared is 1, 1 minus 4 is negative 3. If you have the correct vertex and you go 1 to the left and 1 to the right, what should always be true? Same y values because of the symmetry of a parabola. So if you have your vertex wrong, if you accidentally thought it was negative 5 something and you went 1 to the left and 1 to the right, you wouldn't get the same y values. And again, it helps to have triggers that go off, alarms that go off when you've made a mistake so that you can fix it. One alarm would be if your concavity doesn't turn out to be what you know it should be, and another would be if you go to the left and to the right of the vertex the same distance, but don't get the same y values. All right, I'm going to go ahead and plot those 3 points. Those are 3 of the points on the parabola. I'm not going to connect them yet, and I'll tell you why in a minute. But if I did connect them, would I have a parabola that's concave up like I expected it to be? Yep, so at least I know that's right. What's the axis of symmetry? The vertical line that would go right through the vertex of that. And make sure when you're giving me the equation of a line that you don't just give me a number. It's not just 5, but what's the equation? X equals 5. The axis of symmetry is X equals 5. How do you always find a y-intercept? Let x be 0. So if you let x be 0 or find f of 0, you would have 0 minus 5 squared minus 4. 0 minus 5 is negative 5. Negative 5 squared is 25. 25 minus 4 is 21. I don't want to make 21 tick marks on my x-axis. I'm just going to go up here and label a tick mark 21 and then try my best to, actually I'm not gonna graph it yet. I'm going to hold off on connecting the dots until I get my x-intercepts so that I can make sure I can make those look right on my graph. How do you always find x-intercepts? Let y be 0 or put the 0 in place of f of x. If you put 0 in place of f of x, you have x minus 5 squared minus 4 equals 0, and that's a quadratic equation you need to solve. You know 3 ways to solve quadratic equations. Factoring is one. You could fall out this x minus 5, combine like terms, and then see if it would factor. That would be one way to do the problem. Or if you got it in standard form, you could use the quadratic formula. That's one way to solve the problem. There's actually an easier way to solve this problem. What is it? That's the square root method, where you get the square term on one side, the constant on the other, and then take the square root of both sides. And when I said that, bells and whistles went off to remind you what? Don't forget the plus or minus. So add 4 to both sides. Take the square root of both sides. And when you do, don't forget the plus or minus, the positive or negative square root of 4. That's not the only way you could solve this equation. It's the fastest way you could solve this equation. Now just take it apart into the x minus 5 equals positive 2 or x minus 5 equals negative 2 and solve those two linear equations. My x-intercepts are 3 and 7. I was afraid if I tried to graph before I had those 2 points plotted, I might accidentally not hit them straight on. But now I'm ready to connect some dots. That's a much more precise graph of that function than we would have done just using what we knew about horizontal and vertical shifting on the last test. What is the domain of that function? Negative infinity to infinity. You can either look at the equation and say, well, I could let x be anything in that equation. Nothing would blow it up. That's why the domain is negative infinity to infinity. Or you can look at the graph and say it's going from forever to the left to forever to the right. That's why the domain is negative infinity to infinity. How about the range? Make sure you give it to me lowest to highest. What's the lowest y value on that graph? Negative 4. It's always going to be the y coordinate of the vertex. So from negative 4 up to, what's the highest y value on that graph? There's not a highest. It goes forever up. So the range is negative 4 to infinity. What is the most extreme value of that function? Negative 4, or y equals negative 4. We're talking about the number negative 4, not the horizontal line y equals negative 4. But I've been writing it negative y equals negative 4. And is that extreme value a maximum value or a minimum value for the function? It's the minimum value. This function wouldn't be quite as bad for your profit function of a business. At most, if your Y's are measured in dollars, then the very worst you could do was lose $4. Most of that graph, you're making money. All right, so it's very straightforward. The only thing that takes a little bit of room to find if the equation is in vertex form is the x-intercepts. The x-intercepts take a few lines to solve that equation. Everything else, you can just look at the equation or look at the graph and answer the question very quickly. However, quadratic equations are not always given to you in vertex form so that you can just look at it and see the vertex. Sometimes they're given to you in a different form, and that's called standard form. Just like when you get a quadratic equation in standard form in order to solve it, standard form means one side being in descending order, second degree and in descending order. That's still standard form here. But as soon as you see an equation in that form, such as the example on the next page, you should go, wait, that's not the form where I can just look at it and see the vertex. That example 2 doesn't have the guy in parentheses and the guy on the end. So you can't find the vertex that way. How do you find the vertex? Well, there are a couple different ways you could find the vertex, but the easiest is just use this little formula. The x-coordinate of the vertex is given to you by just taking the opposite of b and dividing that by twice the value of a. So we're going to use that little formula to find the x-coordinate of the vertex. And once we know the x, how will we find the y? Not put 0 in for x, but put whatever this turns out to be for x. If this turns out to be 2, then we'll just put 2 into the function and find the y-coordinate of the vertex. Everything else about the problem is going to be the same. You just have to have a little formula for finding the vertex since it's not in vertex form. In calculus, maybe someday I'll get to teach you where that formula comes from. All right, so next 2 examples. I can just look at example 2 and tell that that parabola is going to be concave up, because the leading coefficient's positive. The vertex, is it in that form? You can just look at it and see the vertex? No. So you have to use the little bitty formula. What is it? Negative b over 2a. And the best way, this just kills me. It's a very simple formula, but I have more folks forget that tiny formula and miss this problem on the test than I have forget the quadratic formula. Most folks memorize the quadratic formula and it gets stuck in your head forever, but you don't use the little bitty negative b over 2a as much, and folks get right here on the test and just go blank. The best way to get this in your head is to associate the words that that little formula stands for. That means on the homework, the first 10 problems you do, write down the words x-coordinate of the vertex is x equals negative b over 2a. Just like you used to do your spelling words in the 2nd grade, if you write that down 10 times, especially if you write it down 10 times a day, that's a bit overkill, but it would be there on the day you needed it on the test. If you wrote that several times between now and test day, then it would be there. You've moved it over to the permanent side of your memory. You can never get rid of it again. All right, negative b is just the opposite of b, or the opposite of the coefficient of the first degree term. Negative 6. The denominator, 2 times a, that's 2 times the leading coefficient. So the x-coordinate of this vertex is negative 3. That's just the x. How do I find the y? Put that back in the place of x in the original function. As a matter of fact, I think I'll go ahead and just put it in the middle of my XY chart. And then go one to the left and one to the right so that I have the exact width of this parabola. 1 to the left of negative 3 is negative 4. 1 to the right of negative 3 is negative 2. Does it matter in what order you write those x's? Not at all. This parabola has infinitely many points on it. You could find them in any order you wanted to find them and still have the right graph. So don't worry about order there, but those are the 3 x's for which you need to find the y values. If you can do it in your head, yay, I'm so happy. If not, grab your calculator, make sure you punch it correctly. Most calculators, if you plug in a negative for x and then square it, you're going to have that negative inside parentheses, or the calculator's smart enough to go, oh, the negative's not part of the base. So if you were punching this on the calculator, you would say parentheses around negative 4 and then square plus 6 times negative 4 plus 5. Or if you're doing it in your head, negative 4 squared is what? 16. 6 times negative 4 is negative 24. 16 minus 24 is negative 8. Negative 8 plus 5, negative 3. Again, if you can do it in your head, yay, but I'd rather you do it on the calculator and get it right than do it in your head and miss it. Same thing when I let x be negative 3. When I let x be negative 3, I would have 9 minus 18, that's negative 9, plus 5 is negative 4. And if I let x be negative 2, I would have 4 minus 12, that's negative 8. Negative 8 plus 5 is negative 3. The fact that I got the same y values when I went 1 to the left and 1 to the right of the vertex makes me pretty confident that I have the right vertex. If I graph it and sure enough my parabola is concave up, then I'll be right or I'll be very, very unlucky. It would be pretty weird if all the stars lined up and you still missed it. That probably won't happen. So the vertex, we have the whole vertex now, not just the x. The vertex of this parabola is negative 3, negative 4. And I'm going to go ahead and plot the 3 points that I have on my XY chart. I'm just not going to try to connect them until I get some other stuff. If I did connect those, would I have a concave up parabola? Yes. So second thing has checked out. What's the axis of that parabola? The vertical line that goes through the axis or goes through the vertex would be x equals negative 3. And again, give me an equation, not just a number. How do you find the y-intercept? Let x be 0. That's the easiest thing in the world for a quadratic equation in standard form. Look at this. If you let x be 0, what happens to those first 2 terms? They give you 0. That's just 0 plus 0 plus 5. So if you have an equation in standard form and you let x be 0, y is just going to be the constant. And I'll go ahead and plot that point, 0, 5. How do you find the x-intercepts? Let y be 0 or set the whole function equal to 0. And either use factoring, square root method, or quadratic formula. Which one would be easiest on solving that equation? That will factor. There are factors of 5 that have a sum of 6. That factors into x plus 5 times x plus 1. And if you set each of those factors equal to 0, what would you get for the 2 x-intercepts? Negative 5 negative 1. Here's negative 1, negative 5. Now I have enough points to graph that parabola fairly precisely. What's the domain of that function? For all quadratic functions, the domain is negative infinity to infinity. What is the range? And make sure you give it to me lowest to highest. Lowest y value is negative 4, and it goes forever up to infinity. Is the extreme value of that function a maximum or a minimum value? It's a minimum, and what is that minimum? Negative 4. You could write y equals negative 4, but you don't have to because you're just talking about a number, not the equation of a line. Does anybody have any questions? Let me tell you the most common phrase that I hear the day after I cover new material after handing back a test. For 23 years now, I've heard folks filing out the door saying, I understand this better than what was on the last test. Guess why? Because I'm doing it, not you. And it's fresh. You've just now seen it. Everything that makes perfect sense to you right now and seems so easy, how will it feel when you see it on a test if you haven't looked at it since tonight? Holy crap, what is this? I've never seen this in my life. So just because something seems easy the day we go over it doesn't mean that it's going to be there for you on the day of the test. I can almost guarantee you that it won't be there on the day you take the test unless you've practiced it repeatedly after today. That's why I give you the practice test 2 weeks in advance, so you can go back and dig up these examples to remember how to do each problem and then practice those techniques enough to make it stick in your head. All right, one more before your favorite thing, the applications. Example 3. F of x equals negative x squared minus 5x plus 14. Just to make sure you punch your x values correctly on the calculator, if I were you, I would write that as negative 1 times x squared. Even if you don't write it down that way, you have to think of it that way to punch it correctly on the calculator. Is this parabola going to be concave up or concave down? Concave down because the leading coefficient is negative. Can you just glance at it and tell me what the vertex is? Nope, it's not in vertex form, so what do you have to use? The little bitty formula, negative b over 2a, which you will forget by tomorrow if you haven't written it down a few times before then. The x-coordinate of the vertex is negative b over 2a, which for this example would be the opposite of negative 5 over 2 times negative 1. Is that a positive x value or a negative x value? That's a negative. This just kills me in college algebra when folks are still making sign mistakes like a negative times a negative is a negative. No, it's not. This is a positive divided by a negative is a negative. And you could either write it -5/2, or if it would help you graph it better, you could write it as a mixed number. Or a decimal, -2.5, whichever way you think about it, the best. That's the x coordinate of the vertex. How do I get the y coordinate of the vertex? By just substituting the x. Which one of these would seem simplest to put in the place of x in that equation? An improper fraction, a mixed number, or a decimal? I think probably the decimal. Yeah, just make sure you punch it correctly as -1 times, and then in parentheses, -2.5 squared. -5 times -2.5, then plus 14. Somebody tell me what you got. 20.25, 20 1/4. Okay, I'm not going to count by ones on this y-axis then. I didn't really remember it being that big, but I think that's right. Yeah, -20 1/4. That's what you're saying, right? Oh, yep, that makes sense. I'll tell you why I knew that made sense in just a second. If I had missed that sign, my parabola would not have come up concave down. It would have come up concave up, and I would have to be alert enough to go, hey, wait, something's wrong. And then I could have gone back and found that mistake. So the vertex is -2.5. And then 20 1/4. On the test, I would count that right, whether you gave me mixed numbers or decimals or improper fractions. But on the homework, read the directions and see how my math lab wants you to give it. If it wants you to give an improper fraction, then make sure you give it as an improper fraction. It's frustrating to do all of that work correctly and not read the directions and just type it in wrong. What is the what is the axis of symmetry for this parabola? It's got to be a vertical line, so it starts x equals, and it goes through the vertex, so x equals -2.5. Maybe I'll count by twos on my y-axis. I don't want 20 little tick marks. You can count by anything you want to, but if you're counting by anything other than 1, you have to label it. If you have no labels, I assume you're counting by 1. So if you're counting by twos, at least label that first tick mark 2, and then I'll assume all the others are counting by 2. Oh no, I ran out enough room. I don't have enough room. Play like I got all the way up to 10 tick marks. So -2.5, 20 1/4 would be way up there. How do you get the y-intercept? Let x be 0, and because that's in standard form, you can just glance at it and say, if I let both of those x's be 0, all I'd have left is what? 14. 1, 2, 3, 4, 5, 6, 7, since I'm counting by twos. How do I find x-intercepts? Let y be 0 or set the whole function equal to 0. And would that quadratic equation be easiest to solve by factoring, square root method, or quadratic formula? There's just a difference in opinion. Some folks think factoring's easiest. Some folks think quadratic formula is easiest. It doesn't matter to me how you find those. But I think if I factored out a -1, yeah, if I factored out a -1, then I would just need factors of 14 that have a difference of 5. I think I could find those faster than I could use the quadratic formula. Yep. -1 times x plus 7 times x minus 2. And check your factoring. When you set -1 equal to 0, does that give you a solution? No. -1 doesn't equal 0 no matter what x is. When you set the other two factors equal to 0, what do you get for the x-intercepts? -7 and +2. Whew. I just need to pick a problem with smaller numbers. Because -7 is going to be way out here. Yeah, I counted by 2s on my y-axis. I counted by 1s on my x-axis. It doesn't matter as long as if you're counting by anything other than 1, make sure you label at least 1 tick mark for me. I didn't use my XY chart here to find 2 other points. I could. It really doesn't matter the distance I go to the left and to the right. As long as I go the same distance left and right, I should get the same Y values. Well, can you see that the vertex is the same distance from each of the x-intercepts? And they both have the same Y value? That's good enough. On the test, if I say find 2 points other than the vertex x and y intercepts, you can, but I don't think I say that. That's really all you need to graph it, and those x-intercepts determine exactly how wide the parabola is, so you don't need 2 other points. Why does that parabola look so much wider than my second example if both of them have coefficients that are either 1 or -1? That's not why. It's because of the way I labeled my tick marks. Counting by 2s is going to stretch your graph out more than just counting by 1s. Actually, if you did them on the same graph, they would be the same width. One is concave up, one is concave down. All right, what's the domain of that function? You better get that right on the test. The domain of any quadratic functions, -infinity to infinity. What's the range? Make sure you give it to me lowest to highest. 20 1/4. In the homework, just make sure you're reading to see, how they want you to put that in. And is the extreme value a maximum or minimum value? It's a maximum, and it is what? 20.25, or 20 1/4 is the maximum. everything is the same about vertex form and standard form, except for standard form, you have to use a little bitty formula to find the vertex. Everything after that's the same. And on the test, a whole lot of folks get a problem like this right because they can just look at it and see the vertex, but they get number 2 on the test wrong just because they forget that little bitty formula. So watch out for that. All right. Once upon a time, did I tell you that variation problems are my favorite word problems? I lied. These are my favorite word problems because they seem so wordy and difficult, and yet that first problem can just be boiled down to what's the highest point on this parabola. You could toss out all the words if I just said, here's a quadratic equation. What's the y-coordinate of the vertex? That's exactly what this is asking. Let's see why. The problem boils down to just that. Big old ugly function, I'm not even going to read it all, models the percentage of the U.S. population whose age is X that have earned an advanced degree, which is more than a bachelor's degree, in March of 2003. All right? Stop right there and think about what that equation is. If I wanted the percent of 40-year-olds that have more than a bachelor's degree, how would I find the answer to that question? Just put 40 in the place of X, because X stands for an age, and P stands for the percent of U.S. citizens at that age who have more than a bachelor's degree. So I understand what the variables stand for. I understand what that function's about. If I said, at what age does 30% of the population have more than a bachelor's degree, that would be much harder to solve, but I'd have to let P be 30 and solve for X using the quadratic formula because I don't think I could factor that. We're not asked either one of those things. We're asked, what is the age for which the highest percent of Americans have earned an advanced degree? Just think about it for a second. At what age? What do you think would be the age where more people that age have advanced degrees than any other age? How much? You think it would be in the 20s? Well, I'm thinking probably not in the 20s because in the 20s, most folks just haven't had time to get an advanced degrees. Maybe in the 30s. How about folks in their 80s? There were less people who got advanced degrees 80 years ago. So it's probably not 20s or 80s. It's probably somewhere in the middle. If we graphed this parabola, what could you immediately tell me about it or what to expect? It's concave down. All right. So if I graphed it, come on, pen. If I graphed it, this is very rough sketch, but it would be a concave down parabola. And there would be some magic point where the percentage is higher than for any other point on that graph. I'm looking for the maximum value of that function. As a matter of fact, it occurs at the vertex. So all of these next words, what is the age for which the highest percent of Americans have earned an advanced degree, and what is the highest percentage? All of those words could just be, what's the vertex of this parabola? Because that's where the highest point occurs. There's going to be some age. That's the X value. And then there's going to be some percent. That's going to be the Y value, or in this case, the P value, since this function is named P equals blah, blah, blah. How do I find that vertex? Is the equation in such a form that you can just look at it and see the vertex? No. So you're going to have to use negative b over 2a. That would be negative 0.815 divided by 2 times negative 0.008. Now, just to make the calculator punching easier, rather than typing those negatives on the calculator, what do you already know the sign of that answer is going to be? Yeah, it's a negative divided by a negative, so it's going to be positive. Also, a negative age doesn't make sense. So I know it's a positive. I'm just going to punch 0.815 divided by, be careful how you type that denominator in. Either you're going to have to say 0.815 divided by parentheses 2 times 0.08, so that the calculator's dividing by that whole thing, not just the 2. Or you can punch it 0.815. Oh, did I leave out one? Yes, I sure did. Thank you. Either you can punch it that way or that way, but I think this would make more sense to most folks. 0.16, 0.8. That's 50 something, isn't it? $50.93, darn close to 51 years. A higher percentage of 51-year-olds have advanced degrees than any other age. At least that was the case in 2003. More than a bachelor's degree. So a master's or a PhD or a doctor, yeah. Yeah, anything higher than a bachelor's degree counts. All right, so we found the age because it was the x-coordinate of the vertex. We just used a little formula for x-coordinate of the vertex. Now we want to find out what that percentage actually is. How could I find the percentage of 51-year-olds that have advanced degrees? Just, why would you let it be 0? Yes, I'm looking for the y of 51 years. So let x be 51. If you let x be 0, you would be finding the age at which you'd be finding the percent. Well, that's hard to say. If you let x be 0, you would be finding the percent of 0-year-olds that have advanced degrees. And guess what? It would be 0. This would actually give you a negative number. But yeah, no 0-year-olds have advanced degrees. Yes, that is hard to say. Has anybody punched that yet? I don't remember what that turns out to be. So darn close to, let's say 10.77. Let's say 10.8%. Is that what you're telling me? That would take a minute on the calculator, but just put 51 into that function and see what you get. Less than 11% of 51-year-olds had advanced degrees, but still that was the highest percent of any age. I know.
Do you remember that show, the Percentage Show?
No.
With this guy on
Okay. The Percent Show.
The guy that's doing The Price is Right.
Monty Hall?
No.
Oh, that was years and years ago. I don't know. Drew Carey? Yeah, you don't remember. Oh, I've got to look that up on YouTube because I've never heard of a percent show. That just might be my kind of show. Fake posters. Pick me, pick me. That's funny. I tell you what, if I'm chosen, I'll buy tickets for all of you.
They're free.
Yeah. That's why I'll buy tickets for all of you. All right. We have 10 minutes, and this problem is just a little bit more work than the previous one, but shows you another darn good application of quadratic functions. If you are a business major, then one day you're going to end up in business calculus. And the three biggest things that we will talk about are the revenue function, the cost function, and the profit function, which makes sense in a business class. I'm not saying we're fixing to do any calculus here. I'm just saying that if you're a business major, you need to understand what profit means. Would you agree? I have a lot of people in business calculus who don't, and it breaks my heart just like I broke this pen. It makes me so angry I start breaking pens when my business calculus folks don't know what profit means. Let's see. The daily revenue R achieved by selling X boxes of candy is given by R of X, and in business calculus, R of X stands for the revenue function. So if I say, what will my revenue be if I sell 100 boxes of candy? How do you answer that question? Just put 100 in the place of X and punch it on the calculator. That will be your revenue for 100 boxes of candy. The daily cost of selling X boxes of candy is given to me by this function. So if I want to know how much it's going to cost me to make 100 boxes of candy, what will I do? Put in 100, put 100 in for X in the cost function. So you have to understand this is your revenue function, that's your cost function. The A part says how many boxes of candy must be sold in order to maximize the revenue. Well, what kind of equation is the revenue equation? Either starts with a Q or a L. It's a quadratic equation, which means that if we graphed it, what would its shape be? A parabola, and more specifically, you might need to rewrite that revenue function if it bothers you that it's in descending or ascending order. Yeah, make sure that you realize that that's negative 0.04 x squared plus 9.5 x. So more specifically, you know what about that parabola? It's concave down. And because it's concave down, it has a highest point, and it's that highest point that I'm looking for in part A. How do I find the number of boxes? What stands for number of boxes in this problem? X. So how do I find the X that gives me the most revenue? Find the vertex. And how do you find the vertex? Negative B over 2A. Again, the whole problem just boils down to find the vertex using little bitty negative B over 2A, where B is negative 9.5, or where B is positive 9.5, and then you take the opposite. A is negative 0.04. A negative divided by a negative is a positive. All I'm going to punch on the calculator is 9.5 divided by, that would be 0.08. What's 9.5 divided by 0.08? To the nearest whole box, because I can't sell or make a half a box of candy. It's not going to be negative. Yeah, 119. That sounds familiar. I remember that from the last 20 years. Is everybody getting to the nearest whole box, 119 boxes? All right, that's how many boxes I have to sell in order to maximize my revenue, but how do I find what that maximum revenue actually is? Put the number of boxes into the revenue function. R of 119 means put 119 into the revenue function. Somebody get that for me as fast as you can. 9.5 times 119 minus 0.04 times 119 squared. Just $564 to the nearest whole dollar, or was that rounded? 0.06? Let's just call it about $564. So if I sell 119 boxes, my revenue is going to be the most it possibly can be, and that's going to be $564. The next question is, what is the profit function? And this is what my business majors can't do. Bless their hearts. How do you find your profit in business? Oh, all of you are hitting close to it, and that's awesome. Somebody said it dead on. It's just revenue minus cost. That's what the definition of profit is. Profit equals revenue minus cost. So if we let P of X be our revenue function, our profit function, then our revenue function, 9.5x minus 0.04x squared, minus our cost function, 1.25x plus 250. If I distribute that negative completely and then combine like terms, I'll have my profit function. And I'm going to go ahead and write it in descending order. Negative 0.04x squared plus 8.75x minus 250, if I've done all that correctly in my head. $9.50 minus $1.25 is $8.25, not $8.75. Yeah, $8.25, and then minus the 250. My profit function is also what kind of equation? Quadratic, which means if I graphed it, it would be a parabola, and specifically a concave down parabola. So how many boxes of candy are sold to maximize the profit? How do you find that answer? Nope. Find the vertex. It's always the highest point, and the highest point is always at the vertex. So use negative b over 2a, negative 8.25 over negative 0.04 times 2. That's positive darn close to 100. What is some 103? Anybody second that? Or is anybody getting something different? Yeah, I think that's right. I remember. 103 boxes. Now, I have one part of this problem telling me to sell 119 boxes to maximize my revenue, but I have a different part of this problem telling me to sell 103 boxes to maximize my profit. Which is actually the most important in business? Your profit. Maybe to make these 16 other boxes, you had to buy a whole new batch of caramel that you were going to have to throw most of it away. And so making those other 16 boxes, even though your revenue would be higher, your cost would be higher too, and ultimately your profit would be lower. So it would actually be better just to make that 103 boxes instead of the 119. That would be the additional cost to make that extra however many, and that extra additional cost might outweigh the benefit. Has anybody punched this last part? Just find the profit at $103? That's not what I was expecting. Yeah, it ought to be less than the 564. 554, does anybody second that? All right. I don't have a second yet, so I'm not going to write it down. But tell me this one thing. How did you know that my profit...
Your conference is scheduled to end in 2 minutes.
Because the profit had the cost subtracted off, and the revenue didn't have the cost subtracted off. All right. Assignment 12. Work hard, Email me if you need to.